Hi, Gabriel. Good to see you again. I hope you are doing well. So that's our last class about linear inequalities. It's a kind of, what is it? Review questions of this, let's say, chapter or topic, whatever it is, okay? So as you know, we have been talking about linear inequalities. In the first lesson, we practiced how to solve linear inequalities in one variable. And after that, we did questions right involving a system of linear inequalities and applications of linear inequalities. Today, we will have, what is it, a kind of test, all questions up from the past 3 weeks lessons, okay? So I'm sure now you have some idea, okay? And unfortunately, I cannot talk to you face to face. That's why I don't have much idea what is your level, but I'm sure that the students who are studying actually or taking this course, they are much better than their peers at school, right? That's why they are here, because to participate in math competitions or Olympiads, students should have passion for math. Otherwise, you cannot actually just sit and study. It requires a lot of commitment. So let's start actually close. Okay, we have a few questions, and the step by step we will at the same time do revision and solve questions from this test. Okay, starting from the first part. As you know, this test questions, they are grouped, actually they are split into 4 different groups: part A, part B, part C, and the additional questions. In part A, we have simple warm-up questions, let's say. In part B, a little bit harder questions, and the part C and the additional questions. Okay, so as you know, the idea of solving inequality is very similar to solving equations, right? Linear equations. What is the idea? We have to isolate the unknown by applying a bunch of algebraic manipulations. So actually, by applying a bunch of algebraic manipulations, we can transform this inequality into another inequality, which is in the form of ax, right? Less than or greater than, or less than or greater than, or what is this? Greater than or equal to x, whatever it is. I mean, on the left hand side, I mean, we'll try to take the bring this into this form, right? Maybe here we have ax is greater than b. So now take minus x to the left hand side. Here we have 6x plus x. We will have 7x. Less than or equal to, take negative 11 to the right hand side. 1 plus 11, that is 12. And now if you divide both sides by 7, we will get x alone on the left hand side. On the right hand side, we had 12 over 7, right? Actually, on the number line, what is it? It is, so here we have inclusive 12 over 7. All the numbers to the left of this number, it will be the solution. And once again, it's just the first equation. So, and also, I mean, the example solution set will be from negative infinity to 12 over 7 inclusive. 3 different ways. However, the question 2, again, we have to expand and simplify and bring this into the form ax is less than or greater than, or less than or equal to, greater than or equal to b. So now first, if you expand the left hand side, here we have 2x minus 2 minus 3x. On the right hand side, greater than, here we have 4x plus 4 plus 5, that is 9. So now here we have 2x minus 3x, that is negative x. Take 4x to the left hand side. Here we have minus x minus 4x is greater than, here we have 9, right? Negative 2, take to the right hand side. Here we have plus negative x, right? Minus 4x, that is minus 5 times x, greater than 11. Now, how can I eliminate negative 5 from the left-hand side? We should divide both sides by negative 5. And as you know, if we divide both sides by negative 5 or negative number, we have to also change the inequality sign or the direction of inequality sign. So at the time, this x will be less than minus 11 over 5. So that is the solution of this inequality. Or solution set also, we can just write it as, what is it, from minus infinity to 11 over 5, not inclusive. All right, question 3. solve. Now here we have inequalities involving fractions or fraction coefficients. Let's use blue here. Right. Okay, so here in the denominators, we have 3 and 2, at least common multiple of 2 and 3. We know that it is equal to 6. So I'm going to multiply both sides by 6. If you multiply the first fraction by 6, 6 times 1 over 3, it is 2. So here we have 2 times x plus 1 minus the second fraction, 6 times 1 over 2, that is 3 here. Here we have 3x minus 3. On the right hand side, also multiply 5 by 6. Here we have 30. So now we have to expand the left hand side and simplify. 2 times x, it is 2x plus 2, negative 3 times x, negative 3x, negative 3 times negative 3, that is positive 9. On the right hand side, so we have 30. So now here we have 2x minus 3x, that's equal to negative x, greater than, and 2 plus 9, that is 11, take to the right hand side, 30 minus 11, that's equal to 19. But on the left hand side, we do not have x, right? We have negative x. Negative x means that negative 1 is multiplied by x. So if I just multiply both sides by negative 1, we can have x alone on the left hand side. So at the time here we have x, because negative 1 times negative x is x. And since we are multiplying both sides by a negative number, also we have to change the direction of this inequality sign. On the right hand side, we have negative 9. All right. How about question 4? In question 4, let me use green here. As I say, the denominators are negative 5 and negative 15, right? So I can multiply both sides by negative 15 because least common multiple of negative 5 and negative 15, that is negative 15. Or just ignore the sign, it's just 15. So now if I multiply both sides by negative 15, what happens here? Here we have negative 15 times 1 over negative 5, that's equal to 3, right? That's the first part. So here we have 3 times 2x minus 1 minus negative 15 times 1 over negative 15 is just 1. So here we have 4x minus 1. And since we have multiplied both sides, or we are multiplying both sides by negative 15, also we have to change the inequality sign, right? The direction of inequality sign. 1 times negative 15, that is negative 15. So now if you expand the left hand side, 3 times 2 is 6, 6 times x. Here we have 6x minus 6 minus 4x minus minus, it is plus 1, less than negative 15. So 6x minus 4x, 6x minus 4x, that is 2x, less than negative 15, and minus 6 plus 1, it is minus 5. Take to the right hand side, it is plus 5, which is equal to negative 10. So now if you divide both sides by 2, here we have negative 10 is divided by 2, which is negative 5. So the solution set is, what is it? All the numbers less than negative 5 will be the solution to this inequality. Okay, that is, what is it? The solution set of this inequality. Gabriel, is everything okay? Good. All right. Question 5. Solution. Find the common part of the following sets. Okay, each one actually represents set. We need to find the common part, right? Usually to find the common part, if you just draw a number line, you can see much easier, much clearer, right? So suppose that's our number line. Okay, that is our number line. And here from -3, 4, 5. Which one is the smallest one? -3. So let me just start from here. So this one is inclusive. That is -3. And after that, we have 4 here. Also, it is inclusive. Okay, there's 4. And here we have 5. It is not inclusive, 5. Okay. So first one says that less than 5. That means that we are talking about all the numbers less than 5. Okay, not inclusive. And the second one is greater than or equal to -3. That means that greater than or equal to 3, either to the right of this number line, right to this number. And the third one is greater than or equal to 4. Let me just write here, greater than or equal to 4, right? So now actually that means that since we're talking about a set, right? I mean, system. So we need to find the common part. Common part means that we have to find the bunch of numbers or the set of numbers, right? Which satisfy all of these conditions or all of these inequalities. That means that if you look at this, where do we have triple lines? Here we have over this interval, we have triple lines, right? Actually, these lines, this is for all of these numbers. So actually, they say the solution set or the common part of this one will be from 4 to 5, not inclusive, or simply, and on the number line, okay, this one is inclusive and this one is not inclusive. That is 4 and this one is 5. Okay, how about with just x? Using algebra expression, x is greater than or equal to 4 and less than 5. That is the common part of these sets. Okay. Question 6. Find the common part of the following sets. The first one says, again, let me just draw a number line. Okay. So -5, -1. Let me just label those numbers. Here we have -5. And after that, here we have -1. And here we have 6. And here we have, actually 6 is not inclusive. So let me just draw empty circle. And here we have, what is it? 6 and 8. Okay, here we have 8. All right. So the first one, x is greater than 6 or less than or equal to -1. Okay, less than or equal to -1. Here we are talking about this region, right? Less than or equal to -1 or greater than 6. So greater than 6, this direction. Okay. And the second one says that x is greater than or equal to -5. So -5 is here, greater than means to the right. So inclusive, including this grade 5, we are talking about this number line. Okay. And third one is x is 8 is greater than x. So that means I can just transform this into this form. That means that x is less than 8, right? X is less than 8 it is this region from 8. Okay. So now since we're talking about 3 different sets, right? So we have to find the regions or intervals which actually contains 3 lines, so triple lines. So here we have starting from here, right? And until here we have triple lines. And also starting from here until here we have 3 different lines. So now how can I write this in set form? Actually, we can just show this in set form. Let's say the solution set, this is how we describe this in math, is from -5 to -1, inclusive and union, that means or, and from 6, not inclusive, to 8. Okay. And how about using algebra expression? That is actually solution set is here -5 less than or equal to x less than or equal to -1, means less than or equal to -1, less than or equal to -1, or here we have 6 is less than x less than 8. Okay. And these are two intervals. If you just pick any numbers from these intervals, either from the first one or the second one, this satisfies all the conditions or all the sets given in the question. Okay. Now let's solve a word problem. So that is a common problem actually in a lot of in inequalities, they show this kind of problem. Just let me check my internet, what happened. Gabriel, can you hear me? Okay, good. My hotspot just a minute. All right. Question 7. There are 20 questions in a test. Okay, 5 marks. Let me just also highlight. We have 20 questions and 5 marks are given for a correct answer. And deduce, let me subtract, right? Deduce 2 marks for a wrong answer and no marks for a blank. John has left 3 blanks. Find the minimum number of correct answers such that he could get more than 60 marks. That means that in such tests, how many questions he has to, or does he have to solve correctly so that he will get, what is it, greater than more than 60 marks. So in this kind of question, if you just make a table, you can see what's going on here much better. Okay, here we are talking about 3 different types of results, right? Number 1 is your answer is correct, and the second one is wrong, and it is blank. Okay, so altogether 20 questions, and he left 3 blank. So this one is 3, and suppose that he solved n questions correctly. And how many questions will be wrong? Since 20, 3 of them are blank, 17 questions are left, and n of them are correct. That means the remaining number will be 17 minus n. Okay, that's the first part. And how about the scoring? I mean, marks for the correct answer, it says it is plus 5. For the wrong answer, deduce 2 marks, means that for each wrong answer, you get negative 2. For the blank, it is 0. Right? So your total score, actually I can just write here, what is your total mark? Will be number of correct answers, that is 5 times n plus, and here we have negative 2 times 17 minus n plus 0 times n. That is your total score, how we calculate this, right? And this should be, says it could get more than 60 marks. That means that we're expecting that it should be greater than 60. It should be greater than 60. Okay, that's it. That's how we model this problem. And now next thing is we have to solve this linear inequality. So first we have to simplify this 5n, negative 2 times 17, negative 34, negative 2 times negative n, that is positive 2n, 0 times n is 0, greater than 60. From here, 5n plus 2n, that is 7n, greater than, take 34 to the right hand side, 60 plus 34, that is 94. Okay, now from here, n should be greater than 94 over 7. So now we can write here, if you just draw a number line, okay, that is greater than 94 over 7. Okay, here we have 91 over 7, and here we have 98 over 7. Actually, this 94 over 7 is between 94 over 7 and 98 over 7. Right? So what is 91 over 7? That is 13. 98 over 7, that is 14. Actually, it should solve at least, right, 94 over 7. Since the number of questions is a whole number, the smallest number that is greater than 74 over 7 is, that is 14. So the answer to this question will be, what is it? 14. So actually, what is it? John has to solve at least 14 questions in order to get a mark of, or marks of greater than 60. Okay, if he's expecting his score to be greater than 60, he must solve at least 14 questions correctly. Otherwise, his score or his marks will be not over or greater than 60. Okay, another question. Solution. Henry is 3 years older than Linda. The sum of their age is bigger than 26, but less than 29. And find their age. So we are talking about two people, that is Henry and Linda. Right? It says find their age. What is the age of Henry? We don't know. Let's say Henry's age is, let's say it is N. And what is Linda's age? It says Henry is 3 years older than Linda, not except for Henry. Let's say Linda's age is N. Then Henry's age will be N plus 3, right? And the sum of their age is bigger than 26, but less than 29. That means, what is the sum of their age? Sum of their age is equal to N plus 3 plus N. That's equal to 2N plus 3. So this 2N plus 3, right? This 2N plus 3 is greater than 26 and less than 29. So we have to find their age. So again, by just applying a bunch of manipulations or algebraic, let's say, operations, we can simplify this or transform this into another inequality where we have a single n in the middle. And first, I have to remove this 3. So if I subtract 3 from all sides of this inequality, 26 minus 3, that is 23, less than 2n plus 3 minus 3, that is 2n, less than 29 minus 3, that is 26. Now, if you divide all sides by 2, because we're dividing by positive number, it does not change the direction of the inequality sign. So here we have 23 over 2 less than, here we have n less than 26 over 2, that's equal to 13. Okay, so actually, if you just write this, illustrate this answer on the number line, here we have 23 over 2, not inclusive, and here also we have 13. And 23 over 2 is, what is it? 11.5. And between these two numbers, we have only single integer. That is, what is it? 12. 12 is between 11.5 and 13. And since when we talk about the age, right, usually we actually express or represent our age by whole numbers. So which means that here n should be equal to 12. So since n is equal to 12, what is Henry's age? It is 12 plus 3, that's equal to 15 years old. How about Linda's age? Linda's age is 12 years old. Okay, so these are the age of these people, 12 years old and 15 years old. All right, now part B. Okay, this is was about all question from part A. Now part B. Given that the inequality 5x minus m less than or equal to 0 has two positive integral solutions only. Integral solution means that the solutions are integers. Find the range of possible values of m. So we have to find the range of possible values of m. That is the question. Okay. So solution. So here, first we have to solve this 5x minus m less than or equal to 0. I can just take minus m to the right-hand side, or I can add m to both sides of the inequality, right? So here we have 5x less than or equal to m. Now, if I divide both sides by 5, here we get x is less than or equal to m over 5. And it says in the question, it has only positive, right? So that means that x should be greater than 0. So now if I draw a number line, here we have 0, it's not the answer, right? And less than or equal to 5, that means that how many numbers do we have after 0? Only we have 1. So the first solution must be 1. And actually, let's say the second solution is, it is 2, right? Actually, this at the time, this m over 5, it must be between 2 and 3, right? But not inclusive. So since it is so, from here, I can just write that this m over 5, it should be greater than or equal to 2, because if it is 2 also, right, it includes 2. We will have two answers, 1 and 2. These are two positive integer solutions. And on the left-hand side, it must be less than 3. It should not include 3. Otherwise, there will be 3 positive integers. So now from here, if you multiply both sides by all sides by 5, here we have 10 less than or equal to m less than or equal to 15. And that is the range of possible values of m. Sorry, actually m is 15 is not inclusive. Greater than m should be greater than or equal to 10 and less than 15. Okay, let's continue. All right, series. Solve the inequality. Okay. And also in our previous classes, we did similar question. And here what you have to pay attention here is, what is it? The denominator. Because in the denominator involves some unknown, right? That x minus 3. So now, first cases, we know that here x is not equal to 3, because otherwise we will have 0 in the denominator, actually, which is not defined in math. We don't have a division by 0. So now, since here we have x minus 3, and also here we have x minus 3, x minus 3 cannot be equal to 0. So that means that this x is not equal to 3. Okay, x is not equal to 3. If x is not equal to 3, then 1 over x minus 3 is just a constant number. And also on the right-hand side, we have the same thing, right? At the time, our inequality will be reduced into this form. Here we have 5x minus 4 less than 2x plus 7, because all of the things, they cancel each other. Now it's just simple inequality. Take 2x to the left-hand side, 5x minus 2x, that is 3x less than 7, negative 4 to the right-hand side, 7 plus 4, that is 11. So what is x? X is less than 11 over 3. Actually, 11 over 3, it is greater than 3. It is greater than 3, right? So because if you just draw on the number line, here we have 11 over 3, and also here we have 9 over 3, which is, what is it? Which is 3. Actually, the solution is here. The solution is here, right? And we know that this x, actually, it cannot be equal to 3. Maybe I should just draw unshaded small circle to represent this 3. So it cannot be 3. Okay, so at the time dot, the solution will be, what is it? X is less than 3, or it is greater than 3 and less than 11 over 3. Okay, that is the solution set of this inequality. Because we should just, what is it? Exclude 3 from the solution. Okay. solve the system of inequalities. Okay, we should just solve one by one, right? And after that, we will just write the common solution of these inequalities. The first one, okay, I can just write it. Let me just write the first steps here. Multiply both sides by 4. So here we have -8 less than 3 minus 2x. And how about the second one? 2x minus 7 greater than or equal to, expand the right hand side, that is 3 minus 3x. So now if I just rewrite those inequalities here, let me just write the unknowns on the left-hand side, okay? So, or maybe I can take -2x to the left-hand side. Here we have 2x less than, and -8 to the right-hand side, 3 plus 8, that is 11. And how about the second one? Takes -3x to the left-hand side, 2x plus 3x, that is 5x, and take -7 to the right-hand side, greater than or equal to 3 plus 7 is 10. Or I can just simplify this further, right? The first one, divide both sides by 2. X is less than 11 over 2. The second one is x is greater than or equal to 10 over 5. That is 2. So on the number line, you can see that here we have 2 and here we have 11 over 2. The solution is here, right? Between these two numbers. So the solution set, I can just write a single solution set that is, what is it, from 2 to 11 over 2, not inclusive, or as a single algebraic expression, 2 less than or equal to x less than 11 over 2. Okay, these are just 3 different ways of showing the solution set of system of inequalities, right? Actually, generally, we use maybe this method, usually the first method. And this one is sometimes in some books, they may ask you to illustrate your answer on the number line. This is how we show this, or sometimes even we can just shade it like this. Okay, also we can just shade it. So, and it will be easy to see. And this one is just set form, how to express the solution in set form. Okay, question 4. Let me just divide this into 2 halves. Okay. So again, we have just done similar question about the first part, right? Because as see here in the denominator, we have x minus 10, but on the left-hand side and right-hand side, this inequality, we have the same expression. The only case we have to exclude is x is not equal to 10. So now if suppose that for sure x is not equal to 10, I can actually eliminate this 1 over x minus 10 from both sides of this inequality. So at this time, after this, we'll have, here we have the first inequality becomes x plus 2 greater than 7. And how about the second one? Take x to the left-hand side. We have x over 2 minus x greater than 5 minus 9, which is equal to minus 4. Or the first one is x is greater than 7 minus 2, that is 5. The second one is actually here we have x over 2 minus x, that is minus 1 over 2, greater than -4. And here we have x. So if you multiply both sides by -2, here we have x, right? Also, we have to change the inequality sign. Here we have less than -4 times -2, that is 8. Okay. So actually the answer will be between, what is it? It is 5. Here we have 5 and the 8. All the solutions are here. See here, it does not include the, what is it? 10. 10 is outside this region. Anyway, we don't have to consider this. I mean, mention this in the final answer. So dot, 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 the solution of this system is 5 less than x less than 8, or simply set form is, what is it? This is between 5 and 8. Okay. We have 5 questions left. Good. Another word problem related to linear inequalities. Now let's use blue here. N apples are dividing among M children. Dividing, it's not dividing, we should say divided or shared. Anyway, N apples are divided among M children. If each child gets 4 apples, let me highlight this. If each child gets 4 apples, 9 apples are left over. If each of the first M minus 1 children gets 6 apples, the last child gets less than 3 apples. Find N and M. Okay. So we have M apples, right? And dividing, actually it's divided among M children. If each one gets 4 apples, 9 apples are left. So that means that here we have the total number of apples are shared by M children. Each one gets 4. So each one gets 4 and shared by M children. And still we have 9 apples, right? And this is the number of apples shared by M people. And still we have 9 together. It gives us the total number of apples. In the second part of the question, it says that if each of the first M minus 1 children gets 6 apples, since we are talking about that those apples given, right? If the same number of apples are shared by M minus 1 children, each one gets 6. So each one gets 6 and shared by M minus 1 children. And the last child gets less than 3. Okay, I don't know what is that. Okay, he gets X. All right, and since it says less than X, now what is the condition here? I can just write here that X is less than 3 and greater than 0. Okay, because it says that gets. All right, that's why that means that it should be greater than 0. If it is 0 and you are saying that he gets 0 apple, it doesn't make sense, because when you're talking about this, we're talking about the counting numbers. So that is our system that we have to solve this. And since here X is given, right, I'm going to write, I first express X in terms of M and substitute here, and we will solve it for M. If I know M, we can find N. Now from these two equations, the left-hand sides are equal, right, N. That means that this 4M plus 9 should be equal to, if you expand this, here we have 6M minus 6 plus X. So what is X from here? X is equal to, take 6M to the left-hand side, 4M minus 6M, that is minus 2M. Take minus 6 to the left-hand side, 9 plus 6, that is 15. Okay. So now if I substitute, that is our first step, and that's our second step. In the third step, I'm going to substitute here, right? If you substitute there, here we have 0 less than, what is X? Minus 2M plus 15, less than, it is 3. So we have to solve this. First, I have to subtract 15 from all sides. 0 minus 15, here we have minus 15, less than negative 2 times M, less than 3 minus 15, that is minus 12. So now if you divide all sides by negative 2, here we have 15 over 2. Also, we have to change the inequality sign, greater than M, greater than minus 12 over minus 2, that is 6. And what is it actually? That means that M is greater than 6, less than 7.5, right? Again, here we have not inclusive, it is 6, and not inclusive, 15 over 2 is just 7.5. And since we are talking about the number of people, it must be a whole number or positive integer. The only whole number between 6 and 7.5, that is, what is it? It is 7. Okay, so that means that here, then dot, 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 M is equal to 7. If M is equal to 7, what is N? Substitute there, N is equal to 4 times M, that's equal to 7, plus 9, 28 plus 9, that's equal to 37. So actually 37 apples were shared by 7 children. Gabriel, is your school open now? Or still you are having classes online? Still online. I see. Okay. All right. Another question. I need a bit more space. Let me just keep it as. Okay. If the solution sets, that's part C, they are a little bit harder questions. So if the solution set of 2a minus b times x plus 3a minus 4b less than 0 is x less than 4 over 9, find the solution set of this inequality. Okay. So of course, these a and b, they are parameters, right? Or let's say letter coefficients. So to solve this one first, we need to get some information about a and b. How actually they are related? Are they positive numbers, negative numbers, or which one is greater than which one? Okay. So since if you pay attention to what we have here, x is less than, right? So now if I just simplify our inequality here, the first step here we have 2a. Let me just divide into 2. Okay, 2a minus b times, here we have x is less than, take 3a minus 4b to the right hand side. Here we have 4b minus 3a. Okay. So now if this 2a minus b is negative, if I divide both sides by 2a minus b, at the time I have to change the direction of this inequality sign. At the time the solution will be x is greater than. But here it says it less than, which means that actually that forces that here we have this condition, this 2a minus b. I know that that is greater than 0. Okay. Because if it is equal to 0, at the time here we have 0 and something, it will be again less than. Okay, if, for example, let's say it should be greater than or equal to 0. If you consider two cases here, the first case is, suppose that 2a minus b is equal to 0, which means that here b is equal to 2a. Now, if you solve this on the left-hand side, here we have 0 less than, what is b? 2a. That is 8, instead of b, 2a, 8a minus 3a. That's equal to 5a, right? So actually 0 is less than 5a. Now a is positive. At the time we have infinitely many solutions, but actually here it doesn't make sense, right? If a is positive, infinite many solutions. If a is negative, we don't have any solution. Okay, so that's why it's not the case. So the only case here is this 2a minus b must be positive. If it is positive, at the time dot dot dot, the solution will be x is less than 4b minus 3a over 2a minus b. And now since the solution set is x less than 4 over 9, so this thing should be equal to 4 over 9. Now from here, we can get more information about a and b. So if you cross multiply, we just change the marker, this is a different part. So if you multiply both sides by 9, here we have 9 times 4b minus 3a. Less than, not less than, it's equal here, equals 4 times 2a minus, so if you expand this, here we have 36b minus 27a is equal to 4 times 2a, that is 8a minus 4b. Okay, so now take 27a to the left hand, to the right hand side, 8a plus 27, that is 35a. Take minus 4b to the left hand side, that is 40b. Okay, so that means that if you divide both sides by 5, here we have 7a equals 8b. All right, or I can just get this ratio. Actually, a to b is, what is it? That is 8 to 7. All right, and that is the relation between a and b. Now knowing this one, now we have to solve the second inequality. Now we have just done this to get how A and B are related to each other. But still, actually, we know that 2A is greater than B, right? If B is positive, A is also positive. And but we don't know, they may be negative, it may be positive. But what we have to know here is 2A minus B is positive. Okay, now let's continue. The second part, we change the color here. The second part of the question, we have to solve this. So from here, A minus 4B times X is greater than, take 2A minus 3B to the right-hand side. So here we have 3B minus 2A. Okay, so now about this, okay, this A minus 4B, is it positive or not? How do I know this? We don't know, because 2A minus, but I know, but A minus 4B, we don't know. But I'm going to use this ratio there, because I know that A to B is 8/7. And that means that if A is equal to 8K, then B should be equal to 7K. What is K? K is any real number. Okay, it can be anything, because I have no idea. It may be positive, it may be negative. But now if you substitute there, what is A? That is 8K minus 4 times B, 28K. And here we have X is greater than 3 times B. That is 3 times B. It is 21K. It is 21K. And 2 times A, that is minus 16K. If you simplify, here we have minus 20K. X is greater than 21 minus 16. That is 5K. Or if you just divide both sides by minus 20, here we have KX less than minus K over, what is it? 5/20. That's equal to K over 4. That's 5/20, right? So I just divided both sides by 20. Okay, it's a positive. But I have no idea about this K. That's why I couldn't divide this. So now I need to actually consider two cases here. Number one is, again, first one is, what is it? K is greater than 0. If K is greater than 0, the solution will be X is less than minus 1/4. Okay, that's the solution of this system. And actually using this one, I can just write anything for A and B. And the second case is, how about K is less than 0? K cannot be equal to 0, because if K equals 0, A and B will be 0. That means that 2A minus B will be 0. It's not our case. It cannot be equal to 0. If K is less than 0, if you divide both sides by K is negative. You're dividing by K. So at the time this X will be, what is it? Greater than minus 1/4. And these are the solutions of the given inequality, depending on the value of K. Okay. Next question, question 2. We know that that's a perfect square. This is how we call this in algebra. A plus B squared equals, or identically equal to, A squared plus 2AB plus B squared. Because if we just expand this, we will get this expression. And prove that 9x squared minus 6x plus 2 is a positive number for any rational number x. Maybe for any real number, or even we can say that. So here we're talking about this. Let me just label this by P, okay? P of x, that is 9x squared minus 6x plus 2. We have to show that it's always positive. In the question, I have to show that or prove that it's always positive for any rational number x, right? So now, using this idea, in real number system, we know that anything squared is non-negative, right? Because if you just square any real number, the result will be positive or 0. If it is 0, it is 0. If it's not 0, it's always positive. So I'll try to bring this into this form so that then I can write it as a square of something, which actually keeps the sign of the expression unchanged. So here 9x squared, we can write 9x squared as 3x squared. And so here in the formula we have 2, so I need 2 here, minus 2 times, and here we have 3x, right? 3x times, and I can just write here 1. I'm just doing very simple algebraic manipulation. And I need 1 squared here, 1 squared, and 2, and also 1, because I had just written 2 as 1 squared plus 1, because 1 squared plus 1 is 2. Now, if you just look at this part, the first 3 terms, right, they form, it's very similar to this expression, a squared 3x squared minus 2 times 3x times 1 plus 1 squared. That is a squared minus 2ab plus b squared. So now I can just write here as 3x minus 1 squared and plus 1. And something squared, right, is always greater than or equal to 0, which means that this thing is greater than or equal to 0 plus 1. And that's equal to 1. So a number which is greater than or equal to 1 is always greater than 0. And which proves that actually this expression is always positive. Even actually its minimum value is 1. It cannot be less than 1. Okay. So actually, what is the graphical meaning? Actually, we know that it's a quadratic function. Its graph is parabola. So it is something like this. Suppose it's something like this. That means that the graph is always above the line, this one. That is the equation is equal to x, y equals 1. And our function here is, it is p of x. That is 9x squared minus 6x plus 1. Just graphical representation. Okay. Now we have 2 additional questions, and we will finish the class. Gabriel, is everything okay? You are so quiet and you never ask questions, so, or these questions are so easy for you. Are you sure? Gabriel, when are you going to participate in math Olympiads? Are you going to participate in this Olympiads organized by Thailand? I think it's going to take place this week or next week. Math Olympiads. Are you going to participate in any math Olympiads soon? Oh, yesterday. So how was it? Could you solve the questions? Okay. Okay, Gabriel, good. We have 2 questions. Okay, let's do them, and I will finish the class. Given x and y are positive numbers, which satisfy, it is a lot. I need more space for this question. Let me just keep this as single line. Okay. Given that x and y are positive numbers, which satisfy, that's x minus y equals 2 and cx plus y equals 3. Find the range of possible values of c. Okay, so all right, what are we gonna do here? Again, I'll try to transform the system into a single inequality in one variable. And using its solution, we can get other relations, okay? I mean, other possible values of c or y or x, whatever it is. From the first equation, as I see here, I can just write here y is equal to x minus 2, right? So now if you substitute this into our second equation, then here we have cx plus what is y? X minus 2 will be equal to 3. Okay, so now from here, I can just express everything in terms of x. What is x here? So this x, here we have c plus 1 is equal to, take negative to the right hand side, it is 5. So what is x here? X equals 5 over c plus 1. And because since x is positive integer, so also c plus 1 must be positive. Now from here, it says that x is positive integer, right? So from here, that means that this should be greater than 0. Now, if you solve this for, what is it? For x, for c, okay. So that means that x is greater than 0, right? 5 over c plus 1 is greater than 0. Okay, cx, x minus 2, 5, okay, x c plus 1. So when it is positive, the c plus 1 should be positive. So the c plus 1 should be positive because 5 is divided by positive number is positive. Otherwise, it will be negative. So from here, what is c? C is greater than negative 1. And the second one, okay. How about if you just express everything in 1? What happens here? If it is in terms of y, from here, x is equal to y plus 2. Let's say this is the first part, and this one is the second part. Now, at the time here, we have c times y plus 2 plus y is equal to 3. Now, from here, we have cy plus y, and take 2 times c, it is 2c. Take to the right-hand side, 3 minus 2c. Right? Because c times 2 is 2c, take to the right-hand side. Now here y is a common factor, so y is equal to 3 minus 2c, and divide both sides by c plus 1. Again, also this should be positive, right? And now if you just look at the numerator, multiply both sides by negative 1. So here we have 2c minus 3 over c plus 1. It should be negative. So now if you remember how we do this, if you just write here, we have two different expressions here. Let me just write them in. Here we have 2c minus 3, and here we have c plus 1, right? We have at two different points, they change their sign. The first one is negative 1, so this one is negative 1, but it cannot be equal to negative 1. Also, the second one is 3 over 2. The first one to the right of 3 over 2, it is positive, and here it is negative, and it is negative. The second one to the right of negative 1, it is positive, positive, it is negative. So what is the overall result? Here we have, change color, minus minus, minus minus, it is plus, it is minus, it is plus. So in this negative, that means that actually, what is it? The solution is here. So dot, 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 c must be greater than negative 1, and less than, what is it? 3 over 2. And the first condition is c is greater than negative 1. So then actually it satisfies both. So that's the range of possible values of c will be between negative 1 and 3 over 2. One question left. That's the last question, and we will finish this course, 4-week course. Okay. Solve the inequality. Also here, just keep this closed so that we'll have more space. Also, I can just draw a line. Okay. That's our inequality solution. See here, it involves some parameter here, right? A. It is in the denominator. And what can I do? Suppose that actually first, of course, a is not equal to 0, right? And we have to consider two cases here. Number one is, suppose that the first case is, suppose that a is positive. If a is positive, I can multiply both sides by a squared. Also, it will be positive. So the first one will be a times x. So here we have a times x plus 4 less than, here we have a squared, because we multiply both sides by a squared, minus 2x. Now from here, take 2x to the left hand side. Here we have ax plus 2x less than a squared minus 4. X is a common factor, and here we have a plus 2 times x less than a squared minus 4. And a is positive, right? If a is positive, and also a plus 2 is positive. So now I can divide both sides by a plus 2, so x will be less than a squared minus 4 over a plus 2. But now if you just remember, I can just write here a squared. Actually, a squared minus 4, it is 2 squared, it can be written as a minus 2 times a plus 2. So it's a plus 2, a plus, they cancel each other. It's just equal to a minus 2. So that is a solution of this inequality. X is less than a minus 2, where a is positive. Now the second case here is, the second case, suppose that a is negative. So now, even it is negative, right? If you multiply both sides by a squared, still we have actually this a squared will be positive. So it does not change anything here. But only the case here is if a is negative, right? If you just simplify this, I will have until here, it does not change anything. So here we have a plus 2, and here we have x less than, what is it? A squared minus 4. But here a is positive, right? And how about this a plus 2? How do I know about a plus 2? Okay, so that means that actually here we have, I have to consider this case now. Here we have a plus 2 also positive, which means that a is greater than negative 2, right? So a is less than 0, a is less than greater than negative 2. That means that here we are considering this case, right? Here a negative 2 less than a less than 0, right? A is between this, just keep in mind, okay? So now I can divide both sides by a plus 2. At the time dot dot dot, x will be less than, you see here, a squared minus 4 over a plus is just equal to a minus 2, where a is between negative 2 and 0. Now, how about the second case? Let me just write green so you can see the difference here. And how about a plus 2 is less than 0, right? Which means that a is less than negative 2. A is less than 0, a is less than negative 2. So the common part is a is less than negative 2. Now considering this case, okay? At the time here we have x will be greater than, because dividing both sides by negative number. On the right hand side we have a plus 2 again. This will be the solution of this inequality. So let me just put them in a box. Okay, these are the solutions under these conditions. Okay, these are the conditions. So, Gabriel, thank you very much. That's all about linear inequalities. I wish you good luck in your studies. Okay, maybe one day we'll meet again, or if you continue, I think I'll see next week or after that. Okay, thank you very much. I wish you good luck. Stay safe and healthy. Okay, bye-bye.